All right, welcome to part two of or take two of the open source software. I wanted to walk you a little bit through the Linux stuff that we missed on Tuesday, but unfortunately, the first time through, I didn't actually manage to record this. I think maybe before we get started, we should take a look at something. Let's create another note here, and I'm going to throw this up. There are a couple things that I want to be sure you are aware of. The first one is this little poll we have. I will paste this. I pasted this into our Discord, but this is a little poll. If you are out of the Eastern time zone, and I don't mean, by 3 hours. If you're West Coast, we're going to assume that you can still be up in time to make a noon Eastern lab. But if you're substantially away from that, what we want to do is we want to provide you with the opportunity, potentially, I have to see how many of you there are and how many mentors I have, but to attend off hours lab. So if you are outside of the Eastern time zone and you want to try to have a different lab time, again, I'm not sure we can do it, but we're going to give it a shot. If you go to our Discord, right, you should be in our Discord. If you're not in our Discord, you will be after you finish the first lab. Just go here. This is when is good for that. So you will be able to take that and let me know what times you're available so I can try to make something that's available for as many of you as possible. Let me see. Let's see this. So this is our WebEx, or our Discord, open source software, spring 2019. If you go up to important links, I have a link here. And then I also have a link for something called Nook. And if we click on the Nook link, what you'll find is that it takes us to this little place here. Basically, Nook is going to allow us to run our labs so that I can set you up in tables and have people in the room, and you will be able to talk to one another and we will be able to talk to you. And this is just kind of how it looks. I'm going to try to run our classes, at least our labs in here, and we're going to kind of see how this works for a couple of times. I am going to. I set these up. I'm not sure what happened, but apparently I lost my my schedule that I put in. Regardless, we'll fix that up. I want to see if this is useful. I want to see if it's worthwhile. So I put that link in there as well. If you ever try to come to class and we're not actually having class, this is a good place to check. And the link is again here in our Discord window. The final thing is, if you are watching this remotely and you need to go to lab, you need to attend the lab. The final thing to do is to actually go to the lab time, or go and find out the lab, where the lab is. If you come into our GitHub, right, log into GitHub or go to GitHub, and you go to arcos/CSCI 4470. Here is our repository for all our stuff. Go into modules, go into 01 introduction, and the lab is right here in a nice, easy to read format. You can go through here and you can figure out what the lab is. And here's the link to our Discord, so you can set up there as well. One final thing, if you ever have problems, the final thing you'll do with your lab is at the end you will submit your file to Submittee, right? And that's over here. This is the Submittee. This is the button you submit. It's due on 2/1/2021 at 11:59 p.m. All right. If you do get lost, if you can get to Submittee, click on Course Home. That will take you right to our repository, so you don't have to type in that big long string. All right. So that's just kind of the housekeeping things that I wanted to go over. We're going to take about 10 or 15 minutes to go over some slides on Linux. I'm not going to go into these in detail. Here's our opening slide again. We always go over licensing, or we often go over licensing, just to make sure that we give proper credit where credit is due. That's one of the few requirements for most open source software. So if it's a requirement and it's this minimal, we should, kind of abide by that. So we will do that whenever possible. This one is a fairly open CC BY is what it's called. Basically, in order to use this, all you really have to do is give credit to the people who went before you. There are different types of CC BY clauses. So take a look at that and read them before you actually go using it incorrectly. But for right now, we are actually using this correctly. There is some reading material for this part of it. It's actually kind of interesting because it's kind of the formation of Linux and some of the foundations of open source software. So please go through and read it. This EU paper is an analysis of the potentials of open source software in terms of economic gains and governmental gains, and reducing costs to the taxpayer in the EU, European Union. And then this is a nice brief history of open source software. There we go. It's a PDF. It's kind of nice. It talks about a lot of stuff. We'll touch on some of this briefly in this class. But in general, please read this. Please know the major players. Please, please understand how things came out. I do have to give you tests. The first test is going to be in a couple of weeks, and we are going to have very limited technical stuff. So you're going to have to know all of these readings that we gave you early and be able to answer questions about them. Okay? That's a good place for me to take them from. So here's a very brief history of kind of Linux and kind of the open source environments. Again, it's handled in better detail, here. But this is kind of a cast of the players and their roles, and we will, kind of refer to this. Please use your readings to learn more details, and please ask questions, or we can have discussions. So here's the main characters. We've got an East Coast, West Coast thing, right? We have Richard Stallman. Richard Stallman launched the GNU project under the GNU General Public License, the GPL. We'll talk about the GPL when we talk about licensing. The general manifesto was that the availability of source code and the freedom to redistribute and modify software are fundamental rights. And he meant this, right? This was a very philosophical standpoint. He was taking a philosophical stand, and this came about, or part of the things that came about, was Richard Stallman was part of a research group at MIT. They were doing a lot of development, and what would happen is you would buy a big piece of equipment, like they bought a Xerox printer, I believe it was, and the print drivers would come with it. But you didn't get a license to the print drivers. You didn't own the print drivers. You didn't have the source for the print drivers. But you would instead, essentially lease it. And things were going great. They were using these printers. And then a version of the operating system changed, and Xerox wasn't supporting the printer anymore, and they no longer had drivers, and the printer became useless. And Stallman, kind of saw that as a fundamental flaw. They paid for the printer, they paid for the software, and now Xerox has decided not to support it. And because Xerox has decided not to support it, the software and the printer become useless to them, and they have no recourse. Well, I think they did actually solve the problem. They wrote their own print drivers, or they actually got a hold of the code. But it kind of got him thinking that, when I buy code, when I buy software, I should get everything in the software. I should get the source code. I should be able to give it to my friends. All of these OILAs that you sign, when you install proprietary software, proprietary games, older versions of Windows, they were depriving you of fundamental rights. You've paid for the software. You should be able to use the software how you want, just like any other transaction. And if I buy a dozen eggs, it's not up. I can do what I want with the eggs. I can give them to my neighbor. I can hatch them and make more eggs. I can, they're mine. They're mine to decide how to dispose of. And software should be the same. Because of that, and because of his belief that philosophically software or data yearn to be free and shouldn't be constrained, he developed the GPL as a viral license. And what that means is the GPL, any code licensed under the GPL, can be freely shared and distributed and modified. But if you modify the code and distribute it, and we'll talk about this again in the terms of licensing, if you modify the code and distribute it, you have to make your modifications open as well. You're not allowed to say, okay, I took this free code. You were nice enough to give me the source. I've made modifications, and now I can release it back, but I'm going to keep my modifications to myself. That's pretty much the one thing that's disallowed. Note that what isn't disallowed is me taking your open source course code and selling it. So, for example, Richard Stallman believed that if I got a copy of his code, either purchased it from him or obtained it, some other way, I get the source code as well, right? The code is free. And if I then want to turn around and sell it to my next door neighbor, maybe I found a way to buy it from Richard for $1, and I can sell it to my next door neighbor and all my next door neighbors for $10,000 a piece. Well, that's just fine. That's perfectly legal. And if you look at it, that's actually the business plan behind some major corporations, like, for example, Red Hat, who takes in a GPL licensed Linux and distributes it and shrink wraps it, makes it nice, makes it usable, guarantees everything works together, provides you technical support, the whole 9 yards. But basically what they're taking is a free piece of software and selling it back to you in a more convenient way for you to use. And they got bought by IBM for somewhere around $4 billion a few years ago. Okay, so that's perfectly legal. It's a valid use of code licensed under the GPL. All right, so Richard Stallman starts doing this, and he starts generating, he's trying to generate a new operating system. And he's starting from the level of utilities. So he's writing all of these GPL licensed utilities that are essentially all the stuff that goes together, like your bash shell, your shells, the daemons, all the stuff that goes together to make the software run. But what he's not writing is the actual kernel, the thing that dispatches the code and does all of that stuff there. But it's a really nice ecosystem of code, right? And it all works together and it runs, and it's a very modular. He's using the Bazaar technique. He's got a bunch of small independent modules. They know how everything works together. They have some standard definitions, and the whole thing works together, works nicely. It can be developed independently. I can be working on a mail tool while you're working on a shell, and somebody else is working on a file browser, right? All of that can run in parallel, and nobody has to stomp on one another. Okay, so they're working on that. On the West Coast, UC Berkeley is working on the Unix system, right? Unix was a predecessor to Linux. It came out of AT&T Labs. You would probably recognize it fairly well. It looks a lot like Linux. The key thing, though, was it was licensed by AT&T Labs. And they had a license on it that essentially allowed you to use it for university research. But commercially, you had to contact them to get a license for it, right? So, and that could generally involve a payment. UC Berkeley is improving the Unix system, and they're creating something called BSD Unix by layering tools and such on top of it to make it more powerful than the Unix, than Unix. Essentially, the same types of tools that Richard Stallman's building on on the East Coast. They're kind of doing it on the West Coast and layering it on top of Unix. Now, BSD Unix was released under the BSD license. And if you've read the BSD license, it's really close to the MIT license, but it's not viral, right? It's also in conflict with the AT&T license, because the AT&T kernel, the kernel of Unix, that small thing at the center, requires, is free of cost to research institutes or for people doing research into operating systems and such, but it's not generally free, and it's not open, right? You don't have the rights to the code. So the BSD part, anybody who has the AT&T kernel, the Unix kernel, can get for free from Berkeley, but they have to first get this kernel part. Okay? So that's kind of the setup. GNU is working on a set of things that work with, essentially a Unix kernel or with a kernel, and Richard Stallman's trying to go towards a completely proprietary system. On the other coast, the BSD Unix system is tools layered on top of AT&T's Unix, which is proprietary. So now we have these two camps building towards operating systems, and both of them believe in this open source thing. Berkeley has theirs licensed, non-copyleft. It's a permissive license, and GNU has their stuff licensed under a copyleft license, which does impose more constraints on somebody using the code. It's not the only thing going on. Tech, Donald Knuth, if you know, he's writing a eternal. I think every 5 years it gets 5 years longer that he needs to complete it. But he's writing The Art of Computer Programming. It's either 4 or 5 volumes. If I looked on my shelves, I could tell you, because I have them because they're kind of cool. But as he's writing The Art of Computer Programming, meant to encapsulate all of the knowledge of computer science, he's finding out that he doesn't have a good way to do it electronically. He doesn't have a good way to publish it. So he's decided to work on Tech, a publishing system, as an open source project. Tech is still alive today. If you look at our slides, these particular sets of slides are all made with LaTeX, the successor to Tech. So a thriving community works there as well. There are also things like Usenet communities. They're trading programs online through billboards. People are downloading the code. People are modifying the code, and they're, working together. If you've tried to get something like Firefox working, or maybe something called XEyes, let's see. Let me see if I can bring up XEyes for a second. Come on, move for me. There we go. All right, can you guys see? Oh, don't do that. Does not want to be on this screen is the problem. Try once more. There we go. Still stretching out. Anyway, this is XEyes. When it's working right, it will kind of follow your cursor around and look. But I'm using a double display, and it's not really enjoying that all that much. But XEyes is just a little toy program, but it's working with an X11 Windows system. It's still a windowing system. It's one of the things that allows, one of the ways of having Windows Linux, sorry, or Unix display windows, kind of like Windows on a PC does it as well. So those are founded by a consortium of companies, and I believe X Windows has an MIT license. Okay, so let's go back to our tale of two Linuxes, of two Unixes, two Unix siblings, I guess. So Bill Jolitz, UCB, University of California, Berkeley, was developing a kernel for i386. What he's decided to do is he's decided that he likes to distribute the BSD software, but the AT&T license is in the way, and he's thinking if somebody could just write something to replace just that kernel, then we're out from under the proprietary license of AT&T, and he's doing that. You can read all about him over here in William Jolitz, but he's working on that. He's coming up with a system for that. And then the man everybody's aware of, Linus Torvalds in Finland. Well, he's kind of stumbled onto this thing, Minix. Minix was a teaching kernel from Professor Tannenbaum, and he's been playing with it. He's not really all that happy with it, but he's decided that he's going to do a Linus kernel or Linux kernel, and he's going to do that. And he doesn't want to write the whole thing. He's taking one of the things we discussed earlier, right? Don't write everything. You don't have to write everything yourself. Everything that's available publicly, all the open source stuff, you can kind of glom onto and use, and it's perfectly legal and encouraged and valued and cherished. So he's writing this modifications to the Minix kernel. He's decided to implement a new kernel that's along the lines of the Minix kernel, and so that he doesn't have to write everything that goes along with it, he's kind of bundling it with the GNU software. And the cool thing is, he beats GNU to the punch, right? GNU has developed this massive set of software, and Linus comes in with the kernel, and now it's called Linux because that was the piece that was missing. It's actually called GNU Linux, the official name, right? GNU is still in there. In fact, GNU gets first billing. But in general, we're going to refer to it as Linux. That is Linus Torvalds kernel coupled with the GPL, the GNU GPL license GNU code. And because GPL is viral, well, that kind of limited the options for the Linux kernel. So they're all licensed similarly. That's one branch of the family. Other branch of the family drives out of Bill Jolitz's work. There were some personality issues in that group. At least that's my understanding of it. And because of that, that group kind of splintered a little bit more. So rather than having one Linux with derivatives like Debian and Ubuntu and Mint and all the ones that kind of bundle off of that, but they're essentially, they differ in their philosophies and in the stuff they pull in and the way they package it, but they're essentially all derived from this Linux, the mainline Linux kernel. We've now evolved into NetBSD, FreeBSD, OpenBSD, but they're all based off of this kernel for i386 that Bill Jolitz started working to replace the AT&T kernel. Okay, so Linux has many GNU Linux distributions, right? Fedora, Red Hat's Fedora, Debian, Slackware, and 386 has developed into essentially three distinct branches, and we can argue about how different that is and all sorts of stuff. But that's essentially where the Linux world stands. So East Coast, you had the development of the GNU Linux family based off of Linus Torvalds' work on the kernel and Richard Stallman's work on the GNU utilities. And on West Coast, you have the BSD utilities, right? They're not the GNU utilities, they're the BSD utilities that were originally built off of the AT&T Unix kernel, and then an implementation of a BSD kernel by Bill Jolitz, or initiated by Bill Jolitz, that's kind of derived into these three separate branches. All right, so that's kind of, again, I said this is going to be a brief history. That's about as brief as I can do. It's not that's kind of the big open source elephant in the room that kind of made everybody stand up and take notice, but there's a lot of other open source projects. Apache www server is open source. Perl is open source. Lots of libraries, bioinformatics. A friend of mine who used to adjunct here had the license plate Perl, which I thought was kind of even more geeky than I'm willing to embrace. R is a statistical language. They have a meeting every year, or I think it's still every year, called the use R exclamation point meeting. So try Googling that. You get all sorts of user stuff. But it's the use R statistical conference. Very vibrant community, very old school. They still do a lot of stuff with mailing lists and Usenet or CTAN and other old-fashioned technologies. Mozilla Firefox, that derived from Netscape's from Mozilla's original Netscape. GNOME KDE, their desktop environments to make your Linux environment look more like Windows. Usability issues. Python, Python just went through a major transition. The person who originally developed Python is kind of stepping back, and it's kind of interesting to watch that go. The community still seems very vibrant and going. Java, Go, I think I can throw Rust into there as well. Open data's become big. There are repositories for things like lung cancers, so that you can do research into detection and volume measurements. I was involved with some of that. Google, in fact, the whole TensorFlow and growth of AI has been enabled by the fact that now we have a whole lot of open data that people can freely access and use, because open data, right? Data wants to be free. That's how ideas are spread. And the fact that I let you have my data means I have no less data than I had before. So it's not taking anything from me. It's sharing things from me. Finally, open research, data and computation's public. We can talk about that in the context of research because that's really cool. It means that it's much easier to validate. If I tell you I have something and it works like this and I write about it, it's going to take you substantial time to re-implement it. If I give you it openly, then that saves a whole bunch of steps, and we can validate or throw away bad branches, code that doesn't work or research that doesn't work much more quickly. No time for questions or discussions because there's nobody here except me, but I just wanted to throw that out. I will post this, and thank you for your attention. And please fill out the survey that I put at the beginning and that I posted into Discord. And please watch our Discord for messages about how we're going to meet and how we're going to run class. One final time, if you go to Submittee, right, you guys should all be familiar with Submittee. Click on Course Home. That will take you right to our front page of our repository. Come into Modules, come into Introduction, and then you can start working on the lab if you haven't already. All right. Thank you very much. I am out of here.